Rajesh. Here the subject electric drives and static control. The topic is about the principles of vector control of induction motor. Let's discuss the abstract regarding to the topic. The sole idea behind the vector control of induction motor is to have an, an electrical electrical drive which most offer superior performance than widely used separately excited DC motor in industry. Further, such a drive should also emerge as robust, maintenance-free, and cheaper alternative of the DC drive. Few years back, separately excited DC motor has been considered as a main workhorse in the industry. This is due to its faster dynamic performance as compared to the induction motor. The faster dynamic response of the DC motor lies into its being a doubly fed motor along with the inherent facility of independent control of the torque and flux in the motor. Before the introduction of the vector control of the induction motor, the methods which enjoy wide acceptability in controlling the speed of the cage induction motor drives are termed as the voltage control, frequency control, rotor resistance control, VF control, flux control, slip power, body control, etc. All these control methods are termed as the scalar control of induction motor, and with these cage motor exhibits inferior dynamic performance as compared to the separately excited D motor. Here the introduction is about the cage induction motor drive with vector or field-oriented control offers a high level of dynamic performance, and the closed-loop control associated with these drive provides the long-term stability of the system. Despite there being no major difference between scalar and vector controls, the latter has some properties which make it favorable as a control system with the high dynamic performance. The vector control is also called as an independent or decoupled control, wherein the torque and flux current vectors are controlled. It is a well-established fact that in vector control mode, the cage motor drive is linearized and it behaves like a fully compensated, separately excited DC motor, wherein the control of armature current directly affects the electromagnetic torque developed by the drive. Similarly, in cage motor, the vector control method two currents in quadrature responsible for the flux and torque production, respectively, are controlled independently, and the response of the torque producing component of current is very fast, thereby providing a quicker control of the torque and hence the drive exhibits a high level of dynamic performance. Here we are discussing about the indirect method of the vector control of an induction motor drive, where we can see the block diagram regarding to the induction motor drive here, which is an indirect method of the vector control. Like here we can see the speed control, fuel weakening, calculation of chaos, alpha and unknown values, 2 by 3 phase transformation, current control, shaft encoder. Like these of many are being involved in this. And this slide we are seeing about the differences between the scalar control versus the vector control. So the scalar is simpler form of motor control with steady state performance, poor dynamic response, low performance drives, high power dissipation. Whereas in the vector, complex mathematical model, vicious control of the AC motors, excellent dynamic response, high performance drives, low power dissipation. Here, the analogy with the DC motor control, there is a close parallel between torque control of a DC motor and the vector control of an AC motor. The DC motor field flux produced by field current is orthogonal to the armature flux produced by the armature current because the vectors are orthogonal, they are decoupled. That is, the field current only controls the field flux and the armature current only controls the armature flux. Here, the analogy with the DC motor control, DC motor like performance can be achieved with an induction motor if the motor control is considered in a synchronously rotating reference frame, where the sinusoidal variables appear as DC quantities in steady state. With vector control, IDS induction motor is similar to that of IQS induction motor, where IF, IA are the DC motors. The principles of vector control. Here the basic conceptual implementation of the vector control is illustrated in the below block diagram. Control, machine, inverse transformation, transformation. These are of the four branches parts, and the barrier among these are of machine learning, where the vector control implementation principle with the machine DE minus DQE are the principles of the vector control. The motor phase currents IA, IB, IC are the converted to IDS and IQS in the stationary reference frame. These are then converted to synchronously rotating reference frame DQ currents. IDS and IQS in the controller. Two inverse transforms are performed from the synchronous DQ to the stationary DQ reference frame. Here we can see the Clark transformation and the path transformation of few such diagrams where both are similar, looking as similar but somewhat different. Here, an acute angle, right angle triangle, opposite side at an angle of 120 degrees and also an angle of 180 degrees were being seen at here, where ISA and IS beta and alpha and beta were equals to IA and 1 by root 3 IA plus 2 by root 3 IB respectively. As like that of the path transformation is one of the thing which is similar to that of the path transformation. But the thing is, angular movement being different. Let's talk about the silent features of the vector control. The transient response will be fast because torque control by AQS does not affect the pulse. Vector control allows for speed control in all the four quadrants without additional control. It automatically links operation to the stable region. Here we discuss about the SVP, WM vectors and sectors. These X switch combination determine plate phase voltage configuration. Here let's discuss the alpha bar, V6 bar, beta bar, V2 bar, V3 bar, V1 bar, which be classified as first degree, second degree, third, fourth, and so on. Like 6 degrees were being present in it, where the vectors divide the plane into the six sectors. The binary representation of two adjacent basic vectors differ in only one. At last, the conclusion tells about the vector control or the field orientation control, which used in high performance drives where oscillation and air gap flux linkages are intolerable. Example, automatic actuators, centrifuges, servos, etc. Where field orientation control AC machines was often every DC machine advantage. Since high computational power silicon devices came to market, it has been possible to realize far more precise digital vector control algorithms. More computational effort and high-speed processors are suitable. That's what on the topic regarding to the electric drives and static control, which tells about the principles of the vector control of the induction motor. Thank you.